On this What Happened Wednesday, we're going over rotational motion. Here we have our rotating body, a torsional spring, and within the torsional spring we have a damper. Not all systems have all three of these components, but this here is a general form that any rotating system could theoretically have. We also have here our inertial coordinate system where we have I sub 1 and I sub 2 like before, but also have to find I sub 3 to go along the direction of our rotation. Down here, we have our equation of motion for a rotating system. Without me even writing that, it should be fairly obvious that there's some similarities here between our linear mass spring damper equation of motion and our rotating one. Whereas before, in our old system, we have a force equal to our mass times our acceleration plus our damping constant times the velocity plus the spring constant times our position. In this case, we have a torsional spring where the spring constant is a function, the spring force is a function of our angular displacement theta. Similarly, we have our torsional damper c times our angular velocity theta dot. And instead of having just mass, we have to account for the fact that we have a moment of inertia the farther out from the origin of rotation you go. So we have our I moment of inertia equals to a moment.